Welcome, dear listener, to the Bedtime Lab, where we explore the universe's mysteries just as you're about to drift into a peaceful slumber. It's a pleasure to have you here with us tonight. Imagine yourself wrapped in a cozy blanket of stars as we journey through some fascinating tales of cosmic wonder. As you settle in, perhaps you'd like to share where you're tuning in from. It's always lovely to think about how we're all connected under the same starry sky. Let me share something interesting about our night ahead. We're going to delve into the captivating world of supernovae and stellar explosions, those brilliant and powerful events that light up the universe. Did you know that when a massive star reaches the end of its life, it can explode with such incredible energy that for a short time it can outshine an entire galaxy? These grand celestial fireworks are known as supernovae, and here's something fascinating. These explosions can release more energy in a few seconds than our sun will produce in its entire 10 billion year lifetime. Can you imagine the sheer scale of that energy? Speaking of the sun, it's not massive enough to become a supernova. Stars like our sun will end their lives by gently shedding their outer layers to form a beautiful planetary nebula, leaving behind a white dwarf. It's the heftier stars, those at least 8 times the mass of the sun, that have the potential to go out with a bang. Now, here's a curious thought. Supernovae are not just brilliant spectacles for stargazers. They play a crucial role in the universe by forging elements beyond iron. Within the intense heat and pressure of these explosions, elements like gold, silver, and uranium are created. So, the gold in your jewelry, or the silver in your cutlery, once came from the heart of a star that exploded long ago. Isn't that just a marvel to ponder? This reminds me of the types of supernovae that exist. There are 2 main kinds, Type 1 and Type 2. Type 1 supernovae occur in binary star systems, where a white dwarf star accumulates material from its companion star, leading to a runaway nuclear reaction. Type 2 supernovae, on the other hand, are the result of a massive star's core collapsing under gravity. Both are spectacular in their own right, each with its own story to tell. And did you know that supernovae are key to the cycling of material in the universe? They scatter the elements they've forged into space, enriching the interstellar medium. This material eventually forms new stars and planets, continuing the cosmic cycle of birth and rebirth. Essentially, we are made of star stuff, as the famed astronomer Carl Sagan once said. Speaking of new beginnings, let's talk about the Crab Nebula. It's the remnant of a supernova that was observed by Chinese astronomers in the year 1054. At its peak, this supernova was so bright that it was visible during the daytime for 23 days. Today, the Crab Nebula continues to amaze astronomers with its intricate filaments and pulsating neutron star at its core. Here's another intriguing fact for you. The closest supernova to be observed in recent times was supernova 1987A, which occurred in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. It provided scientists with invaluable data about the dynamics of supernovae, including the neutrino emissions that were detected, confirming theories about stellar core collapse. And speaking of core collapse, did you know that the remnants left behind by some supernovae are neutron stars, incredibly dense objects that pack more mass than the sun into a sphere only about 20 kilometers in diameter? These stars are so dense that a sugar cube-sized amount of neutron star material would weigh as much as all the cars on Earth combined. Here's something to ponder as you relax further into your pillow. Not all massive stars end their lives in a supernova. Some of the most massive stars, those more than 20 times the mass of the Sun, can directly collapse into a black hole without a visible explosion, a process known as a failed supernova. These mysterious events challenge astronomers to rethink what they know about stellar death. And let's not forget about hypernovae, an even more energetic class of explosion that occurs in some of the most massive and rapidly rotating stars. These extraordinary blasts can lead to the formation of gamma-ray bursts, the most energetic events known in the universe. Can you imagine a flash of energy more powerful than what our entire galaxy produces in a year, all in just a matter of seconds? As you close your eyes and drift deeper into relaxation, think of the vastness of space and the incredible events happening far beyond our sight. Such magnificence and mystery remind us of how small we are in the grand scheme of things, yet how connected we are to the universe and each other. Thank you for joining me on this cosmic journey. Remember, dear listener, that every atom in your body was once part of a star, and as you drift off to sleep, you are cradled by the universe's ancient, gentle embrace. Sweet dreams, and until next time here at the Bedtime Lab. Did you ever wonder how astronomers first began to understand the true nature of supernovae? A fascinating tale involves the discovery of the first recorded supernova in the year 1572 by the Danish astronomer Tycho Brahe. His meticulous observations of this new star helped challenge the prevailing belief in an unchanging universe. It's a wonderful reminder of how curiosity has always driven us to explore and understand the cosmos. Let me share something else intriguing. Supernovae can be considered cosmic time capsules. When they explode, they eject material from the star's interior that has been cooked and altered over millions of years, providing astronomers with a glimpse into the past. This material can tell us about the processes that happened inside stars long before we ever existed. Isn't it amazing how the cosmos holds on to its secrets only to reveal them in the most spectacular ways? Speaking of secrets, did you know that some supernovae can actually be triggered by the merging of two white dwarfs? In these rare events, the combined mass of the two stars exceeds a critical limit, leading to a catastrophic explosion. These are known as Type 1 supernovae, and they serve as standard candles in astronomy, helping us measure the expansion rate of the universe. It's like the universe has its own set of cosmic rulers, and here's something to ponder. The shockwaves from supernovae aren't just dramatic, they're also sculptors of the cosmos. These waves can compress nearby clouds of gas and dust, triggering the formation of new stars. So, in a way, these stellar explosions help to sow the seeds for new generations of stars. Isn't it a beautiful cycle of destruction and creation? Let's talk about something that might surprise you. Supernovae aren't just visible in optical light, but can shine across the entire electromagnetic spectrum, from X-rays to radio waves. This means astronomers can study these events in many different ways, each wavelength revealing a different aspect of the explosion. Imagine being able to see the universe through so many different lenses. Did you know that some supernovae can outshine their host galaxies for weeks or even months? This temporary brilliance allows astronomers to study faraway galaxies that would otherwise be too faint to observe. It's as if these explosions are lighting up the universe, giving us glimpses into the distant past. And here's a fascinating fact. While the sheer power of supernovae is awe-inspiring, they also leave behind intricate and beautiful remnants. The colorful nebulae that form from the expelled material are not only breathtaking to behold, but also rich in information about the life cycles of stars. These remnants continue to evolve over thousands of years, telling a story written in the stars. Have you ever heard of a kilonova? It's a rare event that occurs when two neutron stars collide. These events are similar to supernovae, but even more unusual and energetic. Kilonovae are thought to be responsible for creating many of the heavy elements in the universe, such as gold and platinum. Can you imagine the cosmic fireworks produced when such dense objects meet? Speaking of dense objects, neutron stars, the remnants of some supernovae, have incredibly strong magnetic fields. These fields can be billions of times stronger than Earth's magnetic field, influencing everything around them. In some cases, they can even produce what are known as magnetars, which are neutron stars with fields so strong that they can cause intense bursts of gamma rays. These are some of the most powerful magnets known to exist. And if you think that's fascinating, consider this. Some supernovae have such a powerful inward pull of gravity that they create black holes. These enigmatic objects have gravitational forces so strong that not even light can escape them. It's a humbling thought to realize just how much mass and energy are involved in these stellar endpoints. Did you know that supernovae play a crucial role in the evolution of galaxies? By ejecting heavy elements into space, they enrich the interstellar medium and provide the building blocks for planets and life. Without supernovae, the universe would be a much different and perhaps less hospitable place. And there's another captivating aspect to consider. Supernovae can influence the dynamics of entire galaxies. The energy released during these explosions can drive winds that shape the structure and evolution of galaxies. These cosmic outbursts can even regulate star formation by either triggering or suppressing it, depending on the conditions present. As you contemplate these marvels of the cosmos, here's something to reflect on. The light from some of the supernovae we observe today began its journey across the universe, millions or even billions of years ago. When you gaze up at the night sky, you are seeing a tapestry woven from ancient light. It's a reminder of the vastness of time and space and our place within it. And finally, consider the role of supernovae in the search for extraterrestrial life. By spreading elements essential for life, like carbon and nitrogen, throughout the galaxy, these cosmic events set the stage for the potential emergence of life elsewhere in the universe. It's a comforting thought to imagine that we might not be alone, that somewhere out there, other civilizations might be pondering the stars just as we do. As you drift into a peaceful slumber, ponder the cosmic symphony of creation and destruction playing out across the universe. Each supernova is a note in that grand composition, echoing through the vastness of space and time. You too are part of this celestial harmony, a witness to the wonders of the universe. Sweet dreams, dear listener, as the cosmos whispers its ancient lullaby. Let me take you on another journey through the cosmos and share some more intriguing facets about supernova and stellar explosions. Did you ever wonder what happens to the planets orbiting a star that goes supernova? While the core of the star collapses and the outer layers are hurled into space, the fate of any surrounding planets can be quite dramatic. Some may be engulfed or obliterated by the explosion, while others could be flung out of the system altogether by the gravitational upheaval. Imagine the chaos yet wonder of witnessing such a cataclysmic event from a safe distance. Here's something you might find surprising. Not all supernovae are the catastrophic endpoints of stars. Some can actually leave behind viable seeds for new beginnings. When a massive star goes supernova, its core can collapse into a neutron star or a black hole, but the energy released in the process can also contribute to the birth of new stars in the surrounding interstellar medium. It's as if the star is passing on its legacy to the next generation. Speaking of legacies, have you heard about the cosmic phenomenon known as a pair instability supernova? These occur in extremely massive stars, much heavier than our Sun. Instead of leaving behind a neutron star or black hole, these stars explode so completely that they obliterate all their material, dispersing it into space without a trace. It's a rare and spectacular end, like a final grand performance with no encore. Here's another fascinating tidbit. The shock wave from a supernova travels at incredible speeds, often reaching tens of thousands of kilometers per second. As it races outward, it can heat surrounding gas to millions of degrees, causing it to emit X-rays that can be detected by telescopes. This rapid expansion and heating create a brilliant and short-lived spectacle that echoes the transient beauty of these cosmic events. Did you know that supernovae are not just isolated to distant galaxies? They can and do occur within our own Milky Way. In fact, the remnants of past supernovae have been identified and studied, providing valuable insights into the history and evolution of our galaxy. One such example is the Crab Nebula, which is the remnant of a supernova observed by Chinese astronomers in the year 1054. These ancient records reveal how human curiosity about the cosmos spans across centuries and cultures. On the topic of human curiosity, have you ever imagined how supernova could impact life on Earth? While a nearby supernova could potentially have harmful effects by increasing cosmic radiation, the chances of such an event occurring close enough to affect us are extremely low. Nevertheless, the energy and elements they distribute throughout the universe contribute to the very fabric of life as we know it. Here's a little-known fact that might intrigue you. Certain types of supernovae can produce massive amounts of neutrinos, mysterious particles that are incredibly difficult to detect because they rarely interact with matter. During a supernova, trillions of neutrinos are released in the blink of an eye, passing through space and occasionally through entire planets, including ours, without a trace. It's astonishing to think of these ghostly particles racing through the cosmos, each carrying with it a whisper of the universe's explosive events. And if you find neutrinos mysterious, then consider the role of supernovae in shaping cosmic rays. These high-energy particles zip through space at nearly the speed of light, and supernovae are one of the primary sources of these rays. When they eventually reach Earth, they can interact with our atmosphere, contributing to phenomena like the auroras, and even potentially influencing climate and weather patterns. Now, let's explore something truly intriguing: the concept of a hypernova. Hypernovae are incredibly powerful supernovae, resulting from stars much more massive than those in typical supernovae. They release energy on an unimaginable scale, often resulting in the formation of gamma-ray bursts, which are the most energetic explosions observed in the universe. These bursts can outshine entire galaxies, even if only for a few fleeting moments. And speaking of gamma-ray bursts, did you know that these bursts aren't just the result of hypernovae? They can also be produced by the merger of compact objects, such as neutron stars or black holes. The energy released during these mergers is so immense that it can briefly illuminate vast regions of space, offering us yet another glimpse into the dynamism of the universe. Reflecting on all these remarkable phenomena, it's awe-inspiring to consider how supernovae and their kin have shaped our understanding of the cosmos. From enriching the universe with essential elements to providing natural laboratories for studying physics under extreme conditions, these stellar explosions are both creators and destroyers, constantly reshaping the universe around us. As you ponder the wonders of these cosmic fireworks, remember that we are all stardust, born in the hearts of ancient stars and scattered across the universe by these magnificent explosions. So as you drift gently into sleep, let your dreams be filled with the luminous tales of the stars. Let me share something truly fascinating. The remnants of supernovae are more than just cosmic debris. They are like treasure troves, rich with elements like gold, silver, and platinum. These precious metals are forged in the intense heat and pressure of a supernova, scattered across the universe to eventually become part of planets, asteroids, and even the very jewelry we wear. Imagine that the gold in your favorite ring might have originated from the explosive death of a star billions of years ago. It's a humbling thought, isn't it? Speaking of remarkable transformations, have you ever wondered how a supernova can create beautiful nebulae? The colorful clouds of gas and dust illuminated by the remnants of a supernova are called supernova remnants. These ethereal structures are not just pretty to look at. They also play a crucial role in recycling material back into the cosmos. Over time, they become the birthplace of new stars and planets, illustrating the cyclical nature of the universe. Here's another intriguing fact. There is a type of supernova known as a zombie star supernova. Sounds eerie, doesn't it? This occurs in a binary star system where a white dwarf siphons material from its companion star, gaining enough mass to trigger a thermonuclear explosion. The white dwarf is essentially resurrected from its dormant state, leading to a spectacular explosion known as a Type 1 supernova. It's like a cosmic dance of death and rebirth, highlighting the interconnectedness of celestial bodies. Now, did you know that some supernovae can be so bright they outshine their entire host galaxies? These are called superluminous supernovae, and they can be up to hundreds of times brighter than standard supernovae. The exact mechanism behind their extraordinary luminosity is still a subject of research, but their dazzling display offers a vivid reminder of the incredible power and energy that can be released in these stellar explosions. Consider for a moment the gentle whispers of cosmic time. The light from a supernova can travel across the universe for millions of years before reaching our telescopes. When we observe a supernova today, we're actually looking back in time, glimpsing an event that occurred long before our planet even existed. It's an extraordinary window into the past, allowing us to witness the life cycles of stars across the ages. Surprisingly, not all supernovae result from the death of a star. Some are triggered by a phenomenon known as pair instability, which we touched upon earlier. But did you know that this process can also generate antimatter? When gamma rays in the core of a massive star create pairs of electrons and positrons, it reduces the pressure in the core and leads to collapse and explosion. The fleeting creation of antimatter adds another layer of complexity to these cosmic events. Speaking of complexity, have you heard about the role of supernovae in the creation of magnetic fields? As a supernova remnant expands, it amplifies the magnetic fields around it, contributing to the galactic magnetic field. These fields influence the movement of charged particles throughout the galaxy, shaping the structure and behavior of the cosmic environment. It's like an invisible web woven through the fabric of the cosmos by the force of these stellar explosions. It's also fascinating to think that supernovae have been observed and recorded by cultures throughout history. Ancient Chinese, Japanese, and Arabic astronomers have documented these celestial events, leaving behind records that are still valuable to astronomers today. In some cultures, these bright, sudden appearances in the sky were considered omens or messages from the gods. It just goes to show how deeply intertwined our history is with the stars above. Here's something that may surprise you. Some supernova remnants can produce pulsars, rapidly spinning neutron stars that emit beams of radiation. As these beams sweep across the Earth, they create a pulsing effect, much like a cosmic lighthouse. These pulsars can serve as precise cosmic clocks, helping astronomers measure time and space with incredible accuracy. The precision of these natural timekeepers is nothing short of astonishing. And let's not forget about the role of supernovae in shaping the chemical composition of the universe. They are responsible for the creation and distribution of elements heavier than iron, enriching the cosmic environment with the building blocks of life. Without supernovae, elements like oxygen, carbon, and iron would be far less abundant, making the existence of planets and life as we know it exceedingly unlikely. As you continue to ponder the wonders of supernovae, consider this: the sheer number of supernovae that occur across the universe is staggering. On average, a supernova occurs somewhere in the observable universe every second. Each one is a unique event, contributing to the ever-evolving tapestry of the cosmos. It's a reminder of the dynamic and ever-changing universe we are a part of. Finally, let me share a truly mind-boggling concept: the theoretical possibility of a supernova triggering another nearby star to explode. This is known as a supernova chain reaction, where the shock wave from one supernova compresses nearby gas clouds, potentially leading to the birth of new stars and even triggering other supernovae. It's a cosmic domino effect, showcasing the intricate and interconnected nature of the universe. As you drift into a peaceful slumber, dream of the stars and their explosive cycles of life and death, knowing that you too are part of this grand cosmic dance. Let me share something truly captivating. Supernovae can act as cosmic beacons, helping astronomers map the universe's vastness. Type 1 supernovae, often used as standard candles, have a consistent brightness that allows scientists to measure the distances to galaxies far away. This consistency offers a rare glimpse into the universe's expansion rate, and has even helped confirm the phenomenon of dark energy, accelerating the universe's growth. Isn't it astounding how a single explosion can unravel the mysteries of cosmic expansion? Speaking of unraveling mysteries, did you know that some supernovae have been detected through their neutrinos? These elusive particles are produced in immense quantities during a supernova, traveling through space and time, barely interacting with matter. In 1987, a supernova in the Large Magellanic Cloud was the first event where neutrinos were detected on Earth, heralding a new era of neutrino astronomy. Imagine the journey those tiny particles took, traversing space to reach us and tell their story. Here's another little-known fact. Supernovae are not just about destruction. They can also spark the formation of new stars. In molecular clouds rich with gas and dust, the shock waves from a supernova can compress regions within these clouds, leading to the gravitational collapse necessary for star formation. It's a beautiful reminder of how endings can lead to beginnings, a cycle of destruction and creation that defines our universe. And here's something fascinating. The iron in your blood and the calcium in your bones were likely formed in the fiery heart of a supernova. The elements heavier than iron, such as gold and platinum, are believed to be created during these stellar explosions through a process known as neutron capture. This cosmic alchemy enriches the universe and ultimately our own bodies with these elements, tying us intimately to the stars. It's intriguing to consider that not all supernovae are visible to the naked eye. Some occur within dusty regions of galaxies, or are obscured by intervening cosmic dust, making them invisible in optical wavelengths. However, astronomers have developed ingenious ways to detect these hidden explosions using other parts of the electromagnetic spectrum, like radio waves and X-rays. This ability to see the invisible opens up a whole new realm of discovery. Speaking of discovery, have you ever wondered why some supernovae create black holes while others result in neutron stars? The answer lies in the mass of the progenitor star. When a massive star, exceeding around 20 times the mass of our Sun, undergoes a supernova, its core may collapse into a black hole. Conversely, stars less massive than this threshold often leave behind a neutron star. This delicate balance between mass and fate is a testament to the intricate physics governing celestial objects. Here's an intriguing thought. Ancient supernovae may have impacted life on Earth. Researchers have suggested that cosmic rays from nearby supernovae could influence Earth's climate or even play a role in mass extinctions by altering atmospheric chemistry. While the exact impact remains speculative, it's fascinating to ponder how events light years away could ripple across the fabric of life on our planet. Have you ever heard of kilonovae? These are explosive events resulting from the merger of two neutron stars, which are often preceded by gravitational waves. Unlike typical supernovae, kilonovae are significant because they produce heavy elements like gold and platinum in substantial quantities. The gravitational waves detected from such events provide crucial insights into the physics of extreme gravity and the nature of matter under extreme conditions. Speaking of extreme conditions, did you know that the shock wave from a supernova can travel at speeds of up to 20,000 kilometers per second? This supersonic blast wave moves outward, sweeping up material and heating it to millions of degrees, creating the glowing supernova remnants we observe. The energy and velocity of these shock waves are truly staggering, illustrating the raw power of these cosmic events. In a curious twist, there's a class of supernovae known as failed supernovae. These occur when a massive star collapses directly into a black hole without a visible explosion. While they don't produce the spectacular fireworks of typical supernovae, they offer a window into the final fate of the most massive stars, providing invaluable insights into the life cycles of stars. And let me tell you about the role of supernovae in the cosmic timeline. By dating supernova remnants, astronomers can estimate their ages and piece together the history of star formation in galaxies. These remnants act as time capsules, preserving the signatures of past star births and deaths, allowing scientists to reconstruct the evolutionary history of the universe. Here's something to spark your imagination. Supernovae have been proposed as potential lighthouses for detecting extraterrestrial civilizations. The idea, though speculative, suggests that an advanced civilization might harness the energy of a supernova to send powerful signals across the cosmos, using these events as beacons to communicate across interstellar distances. Finally, consider this. The light from some supernovae can be polarized, providing valuable information about the explosion's geometry and the distribution of material around the star. This polarization is a clue to the asymmetrical nature of the explosion, revealing the complex dynamics at play in these powerful stellar events. It's another fascinating aspect of how supernovae continue to unveil the secrets of the universe, even in their final fiery acts. Did you know that supernovae can actually influence the structure of galaxies? The immense energy released during a supernova explosion can push out gas and dust, shaping the spiral arms of galaxies and even affecting their overall evolution. This cosmic sculpting power helps to define the beautiful patterns we see in the night sky. Now, here's something unexpected. Supernovae can potentially trigger lightning on Earth. Researchers have speculated that cosmic rays from nearby supernovae could ionize the atmosphere, creating conditions favorable for lightning. While this is still a subject of study, The idea that events so far away could influence our planet's weather is quite astounding. Speaking of cosmic influences, did you know that supernovae are responsible for creating the cosmic rays that travel through space at nearly the speed of light? These high-energy particles are accelerated by the shock waves of supernova explosions and can penetrate deep into a galaxy, including ours. While they pose challenges for space exploration, they also offer clues about the origins of these powerful stellar events. Here's a curious thought. Sometimes, supernovae can outshine entire galaxies. In their brightest moments, these explosions can radiate more light than all the stars in a galaxy combined. It's a breathtaking display of nature's power, reminding us of the scale and intensity of these celestial phenomena. It's a rather haunting name for a fascinating process. In some cases, a white dwarf in a binary system can siphon material from its companion star. If the white dwarf accumulates enough mass, it can reignite nuclear fusion and explode as a Type Ia supernova. This resurrection gives a new lease on life to what was once a dying star. And let me tell you about the role of supernovae in the formation of planets. The shock waves from these explosions can compress nearby gas clouds, leading to the formation of new stars and potentially planetary systems. The material ejected by supernovae, rich in heavy elements, becomes part of the building blocks for planets and eventually life. Without these stellar explosions, our solar system might not exist as it does today. Here's something to ponder. Supernovae might have helped shape the Milky Way's halo. This vast, spherical region surrounding our galaxy contains older stars and globular clusters. Supernova-driven winds could have contributed to the distribution of this ancient stellar population, highlighting the significant role these explosions play even in shaping the structure of our galaxy. Speaking of shaping, did you know that supernovae can create cosmic voids? When a supernova explodes, it pushes out surrounding gas and dust, creating a cavity. These voids can influence the formation of new stars by altering the distribution of material in their vicinity. It's another example of how supernovae can impact the cosmic landscape in dramatic ways. And here's a truly awe-inspiring fact. In some cases, supernovae can lead to the formation of pulsars. These rapidly spinning neutron stars emit beams of radiation from their magnetic poles. As they rotate, these beams sweep across the sky, creating a pulsating effect, much like a lighthouse. The birth of a pulsar is a spectacular aftermath of a supernova, and studying them helps us understand the extreme states of matter. Now, have you ever wondered about the connection between supernova and cosmic chemistry? The elements forged in the heart of supernovae are dispersed throughout the universe, enriching the interstellar medium. This chemical enrichment is vital for the diversity of elements we see today, including those essential for life. Every atom in your body heavier than hydrogen and helium has likely passed through a star, continuing a never-ending cosmic cycle. Here's a fascinating tidbit. Supernovae can actually be used as cosmic distance markers. Type Ia supernovae, in particular, are known for their consistent brightness. This makes them excellent standard candles for measuring astronomical distances. By knowing how bright these explosions should be, astronomers can calculate how far away they are, helping us map the universe. And speaking of mapping the universe, did you know that supernovae have played a role in the discovery of dark energy? Observations of distant supernovae revealed that the universe's expansion is accelerating, leading to the hypothesis of dark energy. This mysterious force is thought to make up a significant portion of the universe, and studying supernovae helps scientists unravel this cosmic enigma. Here's something intriguing. Some supernovae are so powerful that they can be detected in other galaxies billions of light-years away. These distant explosions provide a glimpse into the universe's past, allowing astronomers to study the conditions and events that occurred long before our solar system even formed. Finally, consider this. Supernovae can produce gravitational waves, ripples in the fabric of space-time. These waves, generated by the asymmetric collapse of a star, can travel vast distances and provide information about the inner workings of a supernova. Detecting these waves opens a new window into understanding the most violent events in the cosmos, revealing secrets that were once thought to be hidden forever. It's remarkable to think about the many ways supernovae continue to influence the universe and our understanding of it. Let these stellar explosions linger in your thoughts as you drift into a peaceful slumber, knowing that we're all part of this grand cosmic dance. Did I ever tell you that supernovae can occur in different flavors? There are several types, each with its own unique characteristics and causes. For instance, a Type 2 supernova happens when a massive star, much larger than our Sun, exhausts its nuclear fuel and can no longer support itself against gravity. This dramatic collapse leads to a catastrophic explosion. But here's the twist. Despite their size, these massive stars don't always explode completely. Sometimes the core remains intact, forming a neutron star or even a black hole. Can you imagine such a transformation from a brilliant, luminous star to an invisible cosmic entity? And speaking of transformations, have you heard of hypernovae? These are even more powerful than typical supernovae and are associated with the collapse of stars more than 20 times the mass of the Sun. Hypernovae are believed to be the progenitors of long gamma-ray bursts, which are some of the most energetic events in the universe. The energy released in just a few seconds of a gamma-ray burst can outshine everything else in the universe combined. It's a humbling reminder of the sheer power and unpredictability of the cosmos. Here's a curious fact. Not all supernovae result in destruction. In fact, some lead to the creation of beautiful structures known as supernova remnants. These remnants are composed of gas and dust ejected during the explosion, and over time, they expand and interact with the surrounding interstellar medium, creating stunning nebulae. One famous example is the Crab Nebula, which is the remnant of a supernova observed by Chinese astronomers in the year 1054. The intricate patterns and vibrant colors of these nebulae are a testament to the complex beauty that can arise from such cataclysmic events. Did you know that supernova can impact the birth of new stars? When a supernova explodes, the shock wave can trigger the collapse of nearby gas clouds, initiating the process of star formation. This cycle of death and rebirth is a fundamental aspect of the universe, illustrating the interconnectedness of all cosmic events. In a way, supernovae are the universe's way of recycling material, ensuring that new generations of stars and planets continue to form. And here's another intriguing thought. Not all supernovae are visible to the naked eye. Some occur in distant galaxies or are obscured by dust, making them difficult to detect. However, astronomers have developed sophisticated techniques, such as infrared and radio observations, to uncover these hidden explosions. By studying them, scientists gain insights into regions of the universe that are otherwise inaccessible, painting a more complete picture of our cosmic surroundings. Have you ever wondered how supernovae are named? It turns out they are given a designation based on the year of discovery, followed by a letter or combination of letters. For example, SN 1987A was the first supernova discovered in the year 1987. This straightforward naming system helps astronomers keep track of the many stellar explosions they study each year, as hundreds of them occur across the universe. Here's a fascinating connection. Supernovae have played a crucial role in the development of life as we know it. The heavy elements produced in these explosions, such as iron, calcium, and oxygen, are essential components of planets and living organisms. Without supernovae seeding the universe with these elements, life might have taken a very different path. It's a reminder that even the most violent events in the universe can have profoundly beneficial outcomes. And speaking of life's origins, did you know that our very own solar system might have been influenced by a nearby supernova? Some scientists believe that the presence of certain isotopes in meteorites suggests a supernova occurred near the nascent solar system, contributing material that eventually formed the planets, including Earth. This cosmic connection underscores the idea that our planet is part of a vast and dynamic universe, shaped by events both near and far. Here's a surprising tidbit. Supernovae can create cosmic bubbles. As the outer layers of a star are blown away, they can carve out cavities in the interstellar medium. These bubbles, often filled with hot, energized gas, can last for millions of years before eventually dispersing. The creation of these cavities can influence the dynamics of the surrounding space, affecting the movement and formation of future stars. Did I mention that some supernovae have historical significance? For centuries, cultures around the world have recorded these bright, transient stars appearing in the sky. One of the most famous historical supernovae was observed in 1054, marking the birth of the Crab Nebula. Such events have been noted in ancient Chinese, Japanese, and Middle Eastern records, serving as a testament to humanity's long-standing fascination with the heavens. And here's a mind-bending concept. Some theories suggest that the shockwaves from supernovae might influence the evolution of life on Earth. The radiation and energetic particles produced by these explosions could potentially alter the planet's atmosphere, impacting the climate and even affecting the course of biological evolution. While this is speculative, it hints at the complex ways in which cosmic events might be intertwined with life on our planet. As you let these fascinating facts drift through your mind, consider how supernovae, with their explosive final acts, play such a vital role in the grand tapestry of the cosmos. They remind us of the impermanence and interconnectedness of all things, inviting us to ponder our place in this vast universe. Let me share something intriguing with you. Supernovae are not just magnificent cosmic fireworks, they can also be cosmic messengers. When a supernova occurs, it can send out a shockwave of neutrinos, which are almost massless particles that travel close to the speed of light. These neutrinos can pass through almost anything, including entire planets. In fact, they were detected on Earth during the supernova SN 1987A, providing valuable information about the core collapse process of the star. Isn't it astonishing that something so ephemeral and distant can leave such a tangible trace in our scientific instruments? Speaking of neutrinos, did you know that they can also travel through different dimensions? Some theories of physics suggest that neutrinos might interact with extra dimensions beyond the three spatial ones we are familiar with. If true, this could open up entirely new realms of understanding about the universe's structure. Imagine the implications of discovering dimensions that are invisible to our senses yet woven into the fabric of reality. Supernovae in exploding might just be the key to unlocking these profound mysteries. Here's another captivating thought. Supernovae can lead to the creation of new types of stars. When a massive star explodes, its core can collapse into a neutron star, or, if massive enough, a black hole. But in some cases, the explosion can leave behind a type of star called a magnetar. Magnetars are neutron stars with incredibly strong magnetic fields, billions of times stronger than the Earth's. These magnetic fields can cause the surrounding space to behave in unusual ways, emitting bursts of high-energy radiation known as gamma-ray flares. It's a wonder how the remnants of a star's death can give rise to such exotic and powerful objects. Have you ever wondered about the importance of supernovae in the grand scheme of galactic chemistry? Supernovae play a critical role in dispersing elements across galaxies. As a star explodes, it releases elements formed in its core into space, contributing to the cosmic soup from which new stars, planets, and even life are formed. This process is known as nucleosynthesis, and without it, galaxies would lack the diversity of elements necessary to support complex systems. It's humbling to think that the atoms in your body may have once been part of a star that exploded billions of years ago, far away in both time and space. Here's a little-known tidbit. Supernovae might have a hand in creating cosmic rays. These high-energy particles travel at nearly the speed of light and can originate from the remnants of supernovae. As the shock wave from the explosion moves through space, it can accelerate particles to incredible speeds, turning them into cosmic rays. These particles then zip across the universe, sometimes colliding with Earth's atmosphere and creating showers of secondary particles. The very air we breathe is occasionally influenced by these travelers from distant supernovae, connecting us in an unexpected way to the broader cosmos. Did I mention that supernovae can have an impact on the shape of entire galaxies? When multiple supernovae occur in a region, their combined energy can push and pull on the surrounding gas and dust, sculpting the galaxy's structure over time. This process, known as feedback, is essential in regulating star formation and maintaining the delicate balance required for a galaxy to evolve. In this way, supernovae serve as both creators and caretakers of their cosmic neighborhoods, ensuring that the cycle of birth and death continues. Here's something surprising. Not all supernovae are caused by massive stars ending their lives. Some arise from white dwarfs in binary systems. When a white dwarf accumulates enough material from its companion star, it can reach a critical mass and undergo a runaway thermonuclear reaction, resulting in a type Ia supernova. These explosions are so consistent in their brightness that they are used as cosmic yardsticks to measure vast distances in the universe. This ability to act as a celestial measuring tape has been crucial in the discovery of the accelerating expansion of the universe, leading to the concept of dark energy. Isn't it fascinating how the death of a small, dense star can illuminate such profound truths about the cosmos? And speaking of binary systems, did you know that some supernovae might be responsible for creating runaway stars? When one star in a binary system explodes, it can impart a velocity to the surviving companion star, sending it hurtling through space at incredible speeds. These runaway stars can travel hundreds of kilometers per second, carrying with them clues about their explosive origins. They are like cosmic detectives, tracing back their paths to the sites of ancient supernovae, providing astronomers with valuable information about stellar dynamics. It's also worth considering that supernovae might have a hand in the cosmic dance of galaxies. When galaxies collide, the gravitational interactions can trigger waves of star formation, leading to an increased likelihood of supernovae. These explosions, in turn, can influence the merger process, affecting the galaxy's shapes and future evolution. It's as if the universe choreographs an elaborate ballet, with supernovae playing the role of both the performers and the composers of this cosmic symphony. Finally, let me leave you with a thought. Supernova, with their brilliant displays and far-reaching effects, are a testament to the impermanence and interconnectedness of all things. They remind us that even in destruction there is creation, and in chaos there is order. As you drift into sleep, remember that the universe is a vast and wondrous place, filled with mysteries yet to be uncovered, and supernovae are just one of its many extraordinary stories. Let me share something intriguing with you. Supernovae are not only a spectacular cosmic event, but also a rare one. Imagine this. In a galaxy the size of our Milky Way, only about 1 to 3 supernovae occur per century. This means that many galaxies might go hundreds of years without witnessing such a dramatic event. However, there are so many galaxies in the universe that somewhere out there, a supernova is happening more frequently than you might expect. And here's a thought that might surprise you. The light from a supernova can outshine an entire galaxy. For a brief period, often just a few weeks, the light emitted by a single exploding star can be brighter than the combined light of billions of stars in its host galaxy. It's as if a single sparkler were to outshine an entire fireworks display. Have you ever considered the incredible speed at which supernova remnants can expand? When a star explodes, its remnants can be blasted outward at speeds of up to 30,000 kilometers per second. To put that into perspective, that's fast enough to travel from the Earth to the Moon in less than 15 seconds. This rapid expansion plays a crucial role in spreading newly formed elements throughout the cosmos. Here's something that might pique your curiosity. Certain supernovae are linked to the mysterious phenomenon known as gamma-ray bursts. These are intense flashes of gamma rays, the highest energy form of light, and they are among the most powerful events in the universe. Scientists believe that some gamma-ray bursts may occur when massive stars explode in supernovae, marking the birth of a black hole. Speaking of black holes, did you know that supernovae can actually influence the formation of entire clusters of them? In regions rich with massive stars, successive supernovae can lead to the creation of multiple black holes within a relatively small area of space. Over time, these black holes may form into clusters, affecting the dynamics of their host galaxies. Here's another captivating detail. Supernovae have been used to calibrate cosmic distance scales. By studying the light curves of Type Ia supernovae, astronomers can determine how far away these events occurred. This method has become one of the most reliable ways to measure the vast distances between galaxies, helping us map the universe on an unimaginable scale. And have you ever wondered about the impact of supernovae on nearby planets? If a supernova were to explode too close to a planetary system, the intense radiation could strip away atmospheres or even sterilize surfaces, rendering them uninhabitable. Fortunately, supernovae are typically far enough from Earth to pose no immediate threat, but their potential influence on planetary environments is a fascinating area of study. Here's a curious fact for you. The study of ancient supernovae has been aided by artistic depictions from cultures around the world. Historical records and astronomical charts from China, Japan, and the Middle East have provided valuable data about supernovae observed centuries ago. These observations help modern astronomers understand the frequency and characteristics of past stellar explosions. Incredibly, supernovae can also affect weather patterns on Earth. When cosmic rays from distant supernovae interact with our atmosphere, they can influence cloud formation by ionizing atmospheric particles. This process has been suggested as a possible contributor to long-term climate variations, linking supernovae to changes on our own planet. Have I mentioned how diverse these stellar explosions can be? While Type Ia supernovae result from binary star systems, Type II supernovae typically occur when a massive single star runs out of nuclear fuel and collapses under its own gravity. Each type of supernova offers unique insights into stellar life cycles and the different paths stars can take in their lifetimes. Speaking of diverse paths, did you know that the Crab Nebula is the remnant of a supernova that was observed on Earth in the year 1054? This explosion was recorded by astronomers in China and the Middle East and was visible in daylight for several weeks. Today, the Crab Nebula serves as a remarkable example of the beauty that can emerge from stellar destruction. Here's a fascinating connection. Some rare types of supernovae, known as pair instability supernovae, occur when extremely massive stars become unstable due to the production of particle-antiparticle pairs in their cores. These supernovae can result in the complete destruction of the star, leaving no remnant behind, a dramatic end to an extraordinary stellar life. And did you know that the discovery of supernovae in other galaxies was a pivotal moment in astronomy? It wasn't until the early 20th century that astronomers recognized that what they thought were novae in the Milky Way were actually supernovae occurring in distant galaxies. This realization expanded our understanding of the universe and our place within it. Finally, let me tell you about a supernova remnant called Cassiopeia A. Observed in the late 1600s, Cassiopeia A is the youngest known supernova remnant in our galaxy, visible in radio wavelengths. Its study has provided invaluable information about the composition and behavior of supernova remnants, offering a glimpse into the life cycle of stars and the ongoing processes that shape our galaxy. As you reflect on these surprising facts, imagine the countless stories that each supernova whispers across the universe. They're reminders of the profound beauty and complexity that exists beyond our everyday experiences, encouraging us to dream beyond the stars as you drift into a peaceful sleep. Let me share something intriguing about supernovae. They don't only forge heavy elements but also disperse them throughout the cosmos, seeding future generations of stars and planets with the building blocks of life. These stellar explosions are like cosmic gardeners, enriching the universe with essential elements like carbon, oxygen, and iron. Without supernovae, it's likely that our solar system, and indeed life as we know it, would not exist. Now, imagine this. The energy released during a supernova can momentarily outshine an entire galaxy, yet this brilliance is fleeting. Despite their ephemeral nature, the power these explosions unleash is staggering, equivalent to the energy output of the sun over its entire lifetime, but released in just a few days. This sudden burst of energy is what propels the supernova's remnants into space at incredible speeds, shaping the interstellar medium and influencing star formation in far-reaching ways. Here's a thought-provoking fact. Supernovae have played a crucial role in solving one of astronomy's biggest mysteries, the rate of the universe's expansion. By observing distant supernovae, scientists discovered that the universe is not just expanding but accelerating. This groundbreaking revelation led to the concept of dark energy, a mysterious force driving the acceleration, and it earned its discoverers a Nobel Prize in 2011. Did you know that supernovae can trigger the birth of new stars? In regions dense with gas and dust, the shock waves from supernovae can compress these materials, sparking new rounds of star formation. This cycle of death and rebirth is a testament to the interconnectedness of cosmic events, where the end of one star's journey can ignite the beginning of many others. And here's something to pique your curiosity. Certain types of supernovae, like those resulting from white dwarf stars, can serve as cosmic timekeepers. These Type Ia supernovae have a consistent peak brightness, making them reliable standard candles for measuring astronomical distances. Their predictable luminosity has been key in refining our understanding of the size and scale of the universe. Have you ever wondered how astronomers identify supernovae in distant galaxies? It's quite a fascinating process. By comparing images of the same patch of sky, taken at different times, astronomers can spot new bright objects that weren't present before. These transient events often signal a supernova, which can then be studied in detail to uncover its secrets. Here's another captivating detail. Supernovae are not just powerful, but also incredibly diverse. Some, known as hypernovae, are even more energetic than typical supernovae, often associated with the most massive stars and the longest gamma-ray bursts. These hypernovae can be up to 50 times more powerful than regular supernovae, adding another layer of complexity to the study of stellar explosions. Speaking of complexity, let's delve into the peculiarities of supernova remnants. These remnants, like the Veil Nebula, are beautiful but chaotic, showcasing intricate filaments of gas and dust. Over time, they can merge into the surrounding interstellar medium, enriching it with the elements produced in their fiery demise. This process is a key part of the cosmic recycling that sustains galactic ecosystems. And did you know that supernovae can exhibit unique spectral fingerprints? By analyzing the light from a supernova, astronomers can determine the elements present within it. These spectral lines act as a cosmic signature, revealing the star's composition and the nuclear processes that took place during its explosion. It's like reading a stellar autobiography written in light. Reflect for a moment on the broader impact of supernovae on their host galaxies. By injecting energy and momentum into the surrounding interstellar medium, they can regulate star formation rates, influence galactic winds, and even drive the evolution of entire galaxies. This far-reaching influence highlights the role of supernovae as cosmic architects, shaping the universe on a grand scale. Here's a surprising fact you might not have considered. Remnants of ancient supernovae can be found right here on Earth. Scientists have discovered traces of iron-60, a radioactive isotope formed in supernovae, within ocean sediments and lunar soil. These findings offer a glimpse into our planet's cosmic past, hinting at nearby supernova events that may have occurred millions of years ago. Have you ever contemplated the role of supernovae in the search for extraterrestrial life? By spreading essential elements across the galaxy, they provide the raw materials needed for planets like Earth to form. Understanding the distribution and frequency of supernovae can offer insights into which regions of the galaxy might be more conducive to supporting life. And here's another intriguing connection. Supernovae have influenced human culture and scientific thought for centuries. From the ancient Chinese records of guest stars to Tycho Brahe's detailed observations in the 1500s, these celestial events have inspired awe and curiosity, shaping our understanding of the universe and our place within it. Finally, consider the legacy of supernovae in cosmic history. They are among the key drivers of chemical evolution in the universe, transforming simple hydrogen and helium into the rich diversity of elements we observe today. Each supernova is a chapter in the ongoing story of the cosmos, a brilliant yet brief flare that illuminates the vast, unfolding tapestry of space and time. As you let these thoughts carry you into a gentle slumber, Imagine the countless cosmic tales waiting to be discovered, each one a testament to the wonder and mystery of the universe. Let me share something you might find surprising. Not all supernovae are the result of massive stars ending their lives. In fact, some occur in binary star systems, where a white dwarf star siphons material from its companion. Once the white dwarf reaches a critical mass, it undergoes a runaway nuclear reaction, culminating in a spectacular explosion. This is known as a Type 1 supernova, and it's quite different from the core collapse supernova that massive stars experience. Here's another intriguing detail. Supernovae can occur in a variety of environments, from the crowded regions of spiral galaxies to the sparse outskirts of elliptical galaxies. The location of a supernova can influence its characteristics and the subsequent formation of its remnant. For example, supernova in dense molecular clouds can lead to the creation of complex nebulae rich in star-forming material. Did you know that the brightness of a supernova can briefly outshine an entire galaxy? Imagine a single point of light, visible from millions of light years away, momentarily dominating the night sky. This intense luminosity is due to the massive amount of energy released in such a short time. It's a reminder of the incredible power residing within stars. Speaking of power, some stars end their lives in a dramatic fashion known as a pair instability supernova. This occurs in supermassive stars that are hundreds of times the mass of our Sun. In these rare instances, the core becomes so hot that it produces pairs of particles and antiparticles, leading to a runaway reaction that completely obliterates the star without leaving a remnant behind. Can you imagine such a cataclysmic event? Here's something to ponder. The aftermath of a supernova isn't always a nebulous cloud of gas. In some cases, the core of the star collapses into a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons on Earth. These neutron stars can then manifest as pulsars, emitting beams of radiation that sweep across the cosmos, a stunning example of nature's precision and power. And did you know that supernovae are also cosmic alchemists? During the explosive process, elements heavier than iron are forged, enriching the cosmos with materials like gold and platinum. These precious elements are scattered across the universe, eventually becoming part of planets, meteorites, and even life itself. Here's another captivating thought. Supernova can produce cosmic rays, high-energy particles that traverse the universe at nearly the speed of light. These rays can impact Earth, and while they're mostly harmless, they occasionally influence atmospheric phenomena. It's fascinating how events so distant can ripple across space and time to touch our planet. Have you ever wondered about the role of supernovae in galactic balance? By injecting energy and material into their surroundings, they help prevent galaxies from becoming stagnant. This feedback mechanism keeps star formation rates in check, maintaining the dynamic equilibrium necessary for a galaxy's health. Speaking of balance, the gravitational waves produced by certain types of supernovae offer us a new way to observe the universe. These ripples in space-time, predicted by Einstein's theory of general relativity, can provide insights into the inner workings of a supernova, revealing details that light alone cannot convey. It's like listening to the universe's symphony with an entirely new sense. Consider this. Supernovae play a role in the evolution of planetary systems. By triggering star formation in their vicinity, they can set the stage for new solar systems to form. The materials expelled by supernovae, enriched with heavy elements, contribute to the building blocks of planets, asteroids, and eventually, life. And here's something truly unexpected. In the vast timeline of the universe, some supernovae from early galaxies have only recently reached our telescopes. Light from these ancient explosions has traveled across billions of light years, giving us a glimpse into the cosmos's distant past, a time when the first galaxies were forming and the universe was still young. Reflect on this curious fact. While supernovae can destroy their host star, they can also rejuvenate their surroundings. The shockwaves can heat up the gas and dust in nearby regions, preventing them from cooling and collapsing prematurely. This process prolongs the active life of star-forming regions, allowing new generations of stars to emerge. Here's a delightful bit of trivia. The remnants of supernovae, like the famous Crab Nebula, serve as cosmic laboratories where astronomers can study the physical processes that govern the universe. These remnants are filled with intriguing structures, such as filaments and knots, that reveal the complexity of the explosion and its aftermath. As we journey through these cosmic wonders, it's essential to remember the profound impact supernovae have had on our understanding of the universe. From the elements they forge to the mysteries they unravel, supernovae offer a window into the fundamental forces that shape our reality. Each explosion is a reminder of the dynamic and ever-changing nature of the cosmos, a testament to the cycles of creation and destruction that define our universe. Now, as you drift into a peaceful sleep, let the stories of these stellar titans fill your dreams, each one a brilliant point of light in the vast, infinite tapestry of the universe. Let me take you deeper into the cosmos with a surprising fact. Not all stellar explosions are the same. In addition to supernovae, there are less energetic explosions known as novae. These occur in binary systems where a white dwarf accretes material from a companion star. As the material builds up on the white dwarf's surface, it ignites in a thermonuclear explosion. Unlike their more powerful cousins, novae do not destroy the star but instead repeat the process over time. Isn't it fascinating to think of these recurring cosmic fireworks? Here's something else to marvel at. When a supernova occurs in a binary system, it can lead to a gravitational dance of stellar remnants. The explosion can impart a significant kick to both the neutron star and its companion, altering their orbits. Sometimes, this results in high-speed stars being ejected from their galaxies, zooming through the cosmos like cosmic bullets. These runaway stars can travel at such incredible speeds that they might eventually leave their home galaxy behind, embarking on a solitary journey through intergalactic space. Speaking of extraordinary phenomena, did you know that some supernovae are so energetic they are classified as hypernovae? These are 10 to 100 times more powerful than typical supernovae. Hypernovae are thought to be associated with the birth of black holes. As these behemoths form, they can produce intense gamma-ray bursts, the most energetic events in the universe, which briefly outshine all other gamma-ray sources combined. Imagine detecting such a burst from billions of light-years away, a fleeting yet powerful whisper from the universe's past. Now, consider this unexpected twist. Not all supernovae leave behind neutron stars or black holes. In a rare type of supernova, known as a failed supernova, the star's core collapses into a black hole without a visible explosion. Instead of a brilliant flash, the star simply vanishes from sight, leaving astronomers with a mystery to solve. Can you imagine the intrigue of witnessing a star quietly disappearing from the night sky? Let me share another fascinating insight. Some supernova remnants possess magnetic fields so strong they're called magnetars. These neutron stars have magnetic fields 1 trillion times stronger than Earth's. Magnetars can release bursts of X-rays and gamma rays, affecting their surroundings in dramatic ways. Their magnetic fields are so intense that they can distort the very structure of atoms, a testament to the immense forces at play in the aftermath of a stellar explosion. Here's a thought-provoking fact. Supernova might play a role in the evolution of life on Earth. Some scientists speculate that periodic increases in cosmic ray flux caused by nearby supernova could have influenced biological evolution by increasing mutation rates. While this hypothesis remains a topic of research, it's intriguing to consider the possibility that cosmic events could have shaped the trajectory of life on our planet. Have you ever wondered about the different types of supernova light curves? The brightness of a supernova over time reveals important clues about the explosion. Some supernovae fade quickly, while others linger for months. Analyzing these light curves helps astronomers determine the underlying processes at work. Each curve is like a unique fingerprint, revealing the story of the star's final moments. Let's delve into the realm of scale. The energy released by a supernova can briefly equal the total energy output of the Sun over its entire 10 billion-year lifespan. This immense energy is unleashed in a matter of weeks, highlighting the transient yet colossal nature of these cosmic events. It's a humbling reminder of the power and scale of our universe, where events on an unimaginable scale play out in the vastness of space. Speaking of vastness, consider the distances involved. Light from a supernova can take tens of millions to billions of years to reach Earth. When we observe supernovae, we're witnessing events from the distant past, looking back in time to when the universe was a very different place. It's like peering through a cosmic time machine, uncovering the secrets of ancient stars and galaxies. Now, let's explore a cultural connection. Supernovae have been observed and recorded by humans throughout history. Ancient civilizations, from the Chinese to the Native Americans, documented these celestial events, often interpreting them as omens or signs from the heavens. These historical records provide valuable data for modern astronomers, linking past observations with present understanding. Here's an intriguing thought. Supernovae are not only a source of destruction, but also of creation. The shock waves from these explosions can compress nearby gas clouds, triggering the formation of new stars. This cycle of death and rebirth is a fundamental aspect of the universe, ensuring the continual recycling of matter and energy across cosmic timescales. Here's a charming fact. In recent years, astronomers have been able to simulate supernovae in laboratories on Earth, using powerful lasers to recreate the conditions of a stellar explosion. These experiments help scientists test theories and gain insights into the complex dynamics of supernovae, bridging the gap between observation and understanding. And finally, consider the awe-inspiring reality that supernovae are a key part of the cosmic ecosystem, enriching galaxies with heavy elements and driving the dynamic processes that shape the universe. Each explosion is a reminder of the interconnectedness of all things, where the death of one star can pave the way for the birth of others, creating a tapestry of life and light in the cosmos. As you let these thoughts drift into your dreams, may you find wonder and peace in the grand design of the universe, where even the most violent events hold the seeds of beauty and creation. Did you know that supernovae can influence the structure of surrounding galaxies? When a massive star explodes, the resulting shock waves can trigger the birth of new stars by compressing nearby gas clouds. This not only helps in forming new stars, but can also drive the chemical evolution of a galaxy. Speaking of which, the elements created in these explosions are vital for life as we know it. Elements like iron, calcium, and oxygen, which are integral to the structure of planets and living organisms, are forged in the intense heat of a supernova. Imagine the calcium in your bones or the iron in your blood having originated in the fiery heart of a dying star. Here's something fascinating. There are supernovae that are so unusual they are termed superluminous supernovae. These explosions are incredibly bright, sometimes up to 100 times more luminous than typical supernovae. Scientists are still trying to understand the exact mechanisms that power these exceptionally bright explosions, but they offer a glimpse into the most extreme conditions in the universe. Can you picture a single star outshining an entire galaxy for weeks or months? And speaking of brightness, ancient cultures often regarded supernovae as celestial events of great significance. The sudden appearance of a bright new star in the sky was sometimes seen as a divine message or portent. Delving deeper into the mysterious, did you know that some stars end their life in a completely different kind of explosion called a kilonova? Unlike supernovae, kilonovae occur when two neutron stars collide, releasing a burst of energy and creating heavy elements like gold and platinum. The glow from these events is shorter-lived than that of supernovae, but they offer a rare glimpse into the universe's alchemical processes. Imagine, the very gold in your jewelry might have been born in such a cosmic collision. And here's another intriguing tidbit. The study of supernovae has also become a key tool in measuring the expansion rate of the universe. Certain types of supernovae, known as type Ia supernovae, have a consistent brightness which makes them excellent standard candles for gauging astronomical distances. Speaking of cosmic distances, consider the fact that when a star becomes a supernova, it can momentarily emit more energy than the galaxy it resides in. This burst of light travels across the universe, reaching us as a brilliant point of light in our night sky. It's awe-inspiring to think that each supernova we observe is a message from the past, a snapshot of a moment long gone in the universe's timeline. Here's a surprising fact. The closest supernova observed in recent history was supernova 1987A, which occurred in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. This supernova has provided astronomers with a wealth of information due to its relative proximity, allowing them to study the processes in unprecedented detail. Another captivating aspect of supernovae is their role in the cosmic cycle of life and death. When a star explodes, it distributes its elements into space, enriching the interstellar medium with the building blocks for future stars and planets. This recycling of matter is fundamental to the ongoing evolution of galaxies. Did you know that the remnants of supernovae, known as nebulae, can be incredibly beautiful? The intricate shapes and vivid colors of these remnants are not only stunning, but also serve as laboratories for studying the interactions between shockwaves and interstellar material. Let's explore the fascinating fact that not all supernovae are created equal. There are several types, each with unique characteristics and causes. Core collapse supernovae occur when massive stars can no longer sustain nuclear fusion in their cores, while Type 1a supernovae result from the explosion of a white dwarf in a binary system. The diversity in supernova types reveals the complex life cycles of stars, shedding light on the various pathways that lead to these explosive ends. Speaking of pathways, certain supernovae are responsible for creating neutron stars, incredibly dense remnants with masses greater than the Sun but squeezed into a city-sized sphere. The gravity of these objects is so intense that a sugar cube-sized piece of neutron star material would weigh about as much as all of humanity. One more captivating aspect to consider is that supernovae can also influence the potential for life on planets. For example, a nearby supernova could potentially strip a planet of its atmosphere due to intense radiation, affecting its ability to support life. However, it's this very radiation that also helps to create conditions suitable for life in other parts of the galaxy. The balance between creation and destruction underscores the delicate interplay between supernovae and planetary systems. Lastly, think about the fact that supernovae are not just cosmic events, but also beacons for astronomers, guiding them in the quest to unlock the mysteries of the universe. Each supernova observed adds a piece to the puzzle of understanding how stars live and die, shaping our knowledge of the cosmos and our place within it. As you reflect on these wondrous aspects of supernovae, let your imagination wander through the starry skies, pondering the ancient stories written in the light of distant explosions and the grand cosmic dance that continues to unfold around us. May these thoughts gently accompany you into a restful slumber where the wonders of the universe float softly through your dreams. Here's a fascinating idea. Supernovae are not only responsible for creating elements, but they also help distribute them across the universe. Imagine a star exploding with such force that the resulting shockwave propels newly formed elements into the surrounding space. These shockwaves can travel vast distances, stirring the cosmic soup and setting the stage for the birth of new stars and planets. Speaking of stirring things up, did you know that supernovae can trigger the formation of new stars? When their shockwaves slam into nearby clouds of gas and dust, they can compress these clouds just enough to ignite the process of star formation. In this way, a stellar death can lead to a stellar birth, continuing the cycle of creation in the universe. Here's another interesting point. The timing of a supernova's light reaching Earth depends on its distance from us. While the explosion happens in an instant, the light from a supernova that occurred in a galaxy millions of light years away might only be reaching us now. This means we're looking at events that happened in the distant past, offering a unique glimpse into the history of the universe. And speaking of history, the famous Crab Nebula is the remnant of a supernova observed by Chinese astronomers in 1954. This supernova was so bright it could be seen in daylight for weeks. Imagine witnessing such a spectacle with the naked eye, understanding it as a celestial event of great significance. Did you know that not all supernovae are visible to the naked eye? Some explosions occur in distant galaxies, their light too faint to be seen without powerful telescopes. These hidden supernovae remind us of the countless cosmic events unfolding beyond our direct observation. And here's a surprising twist. While we often focus on the visible light from supernovae, they also emit other forms of radiation, such as X-rays and gamma rays. These high-energy emissions help astronomers study the physical processes occurring in the explosion, revealing details invisible to optical telescopes. Let me share something curious. When a massive star explodes in a supernova, it can leave behind a black hole. While neutron stars are common remnants, black holes form when the core of the star is too massive to support itself against gravitational collapse. The idea that a star's death can create such a mysterious gravity-bending object is truly mind-boggling. Speaking of mysterious, some supernovae are puzzlingly asymmetrical. Instead of exploding evenly in all directions, these stars can eject material more forcefully in one direction than another. This asymmetry poses intriguing questions about the underlying mechanisms driving these explosions. Here's another thought-provoking detail. Supernovae can influence the chemical evolution of galaxies. By injecting newly formed elements into the interstellar medium, they enrich the gas that will form future generations of stars and planets. This process gradually alters the chemical composition of galaxies over billions of years. And did you know that some of the first supernovae in the universe, known as Population 3 supernovae, played a crucial role in the early chemical enrichment of the cosmos? These early stars, composed almost entirely of hydrogen and helium, produced the first heavy elements when they exploded, setting the stage for the complex chemistry we see today. Imagine this: supernovae can actually change the dynamics of galaxies. Their explosions can drive powerful winds that sweep through galaxies, redistributing gas and dust, and influencing star formation rates. These galactic winds can even carry material into intergalactic space. And here's something to ponder. While supernovae are relatively rare, occurring maybe once every 50 years in a galaxy like the Milky Way, their impact is profound. Each explosion leaves a lasting mark on the galaxy, shaping its structure and evolution in ways we're only beginning to understand. Another surprising fact is that supernovae can be progenitors of cosmic rays. These high-energy particles, accelerated by the shock waves of supernova explosions, travel across the universe at nearly the speed of light. When they reach Earth, they can affect everything from cloud formation to electronic devices, offering yet another example of the interconnectedness of cosmic phenomena. Speaking of connections, did you know that supernovae can help us learn about dark energy? By observing the light from distant Type 10 supernovae, scientists have gathered evidence for the accelerated expansion of the universe, a phenomenon attributed to dark energy. Here's a final, intriguing insight. While supernovae are often associated with the end of a star's life, in some cases, these explosions can lead to the creation of new, exotic objects. For example, under certain conditions, a supernova might result in a pulsar, a highly magnetized rotating neutron star that emits beams of electromagnetic radiation. Pulsars are like cosmic lighthouses, their regular pulses of radiation providing precise timekeeping tools for astronomers. The interplay between destruction and creation in these stellar explosions is truly a testament to the complexity and wonder of the universe. As you let these surprising facts settle in your mind, picture the vast star-filled sky with its stories of explosive change and rebirth. In the silence of the night, the echoes of ancient explosions weave through the cosmos, a gentle reminder of the ever-turning wheel of life and death in the universe. Allow these thoughts to guide you into a peaceful slumber where the mysteries of the stars whisper softly in your dreams. Let's consider the vastness of space, where supernovae play their dramatic role in the cosmic theater. One surprising aspect is that supernovae can create shock waves strong enough to compress nearby molecular clouds, potentially triggering the birth of new stars. This cascading effect of death leading to life is a remarkable cycle that highlights the interconnectedness of cosmic events. Can you picture the power of these shock waves, rippling through the galaxy, sowing the seeds for future generations of stars? Another fascinating detail is the role of neutrinos in supernovae. Did you know that these elusive particles are released in huge numbers during a supernova explosion? In fact, a significant amount of the energy from the explosion is carried away by neutrinos. These particles pass through matter almost effortlessly, providing critical information about the inner workings of a supernova. Imagine neutrinos as ghostly messengers, revealing secrets from the heart of a star. Here's something intriguing. There are different types of supernovae, each with unique characteristics. Type Ia supernovae, for example, result from the explosion of a white dwarf star in a binary system. These supernovae are used as cosmic yardsticks to measure distances in the universe. The consistency in their brightness allows astronomers to determine how far away they are, helping us map the vast expanse of space. It's amazing how these stellar explosions serve as beacons, guiding our understanding of the cosmos. Speaking of guidance, did you know that supernova remnants can be highly structured, containing complex filaments and knots? This intricate architecture is created as the shock wave from the explosion interacts with the surrounding interstellar medium, sculpting fascinating shapes in the process. These remnants are like cosmic works of art, reminding us of the beauty that can emerge from cataclysmic events. A lesser-known fact is that supernovae can influence the rotation of neutron stars. When a massive star explodes, it can impart angular momentum to the resulting neutron star, causing it to spin rapidly. Some neutron stars, known as millisecond pulsars, rotate hundreds of times per second. The idea that the violence of a supernova can create such rapid rotation is truly astounding. Can you imagine the dizzying speed at which these stars spin? Let's delve into another intriguing aspect. Supernova can produce gravitational waves. These ripples in space-time are generated when the core of a massive star collapses asymmetrically during a supernova. Detecting these waves provides new ways to study these dramatic events and the fundamental properties of gravity itself. Picture the universe as a vast, vibrating tapestry, with supernovae contributing their own unique patterns. Here's a thought-provoking insight. Some supernovae have been linked to gamma-ray bursts, the most powerful explosions in the universe. These bursts release as much energy in a few seconds as the sun will emit over its entire lifetime. The connection between supernovae and gamma-ray bursts suggests that some supernovae might be even more energetic than previously thought, providing a thrilling avenue for exploration in astrophysics. Did you know that supernovae can affect star formation rates in galaxies? By injecting energy and momentum into the surrounding gas, these explosions can either trigger or inhibit the formation of new stars. This delicate balance influences the evolutionary pathways of galaxies, shaping their future development. It's fascinating to consider how the death throes of stars can dictate the birth of others, orchestrating the cosmic dance of creation and destruction. In a surprising twist, supernovae have been used to help us understand the origins of elements like gold and platinum. These precious metals are formed during the rapid neutron capture process, which occurs in the intense environments created by supernovae and other stellar explosions. When you admire a piece of gold jewelry, think about its origins in the fiery heart of a dying star, forged in the crucible of a supernova. Here's an intriguing observation. Supernovae are not just isolated explosions. They can influence their entire galactic environment, creating superbubbles in the interstellar medium. These cavities are carved out by multiple supernovae in a star-forming region, creating vast, hot regions filled with ionized gas. These superbubbles can span hundreds of light years, serving as a testament to the collective power of stellar explosions. As we continue to unravel the mysteries of supernovae, consider this: there is still much we don't know about these mighty events. New discoveries and technologies allow us to observe and understand them in greater detail, revealing just how much there is yet to learn. Each supernova observed by astronomers is like a new chapter in a never-ending story, filled with unexpected twists and enlightening revelations. Reflecting on these surprising facts, you might find yourself gazing up at the stars with a new sense of wonder. The universe is filled with stories written in starlight, and supernovae are among the most dramatic narratives. As you drift into sleep, let these cosmic tales guide your dreams, carrying you on a journey through the vast expanses of space and time. May the stars inspire visions of distant galaxies, where the beauty of stellar explosions continues to unfold, shaping the universe in infinite, wondrous ways. Let me share another captivating aspect of supernovae with you. Did you know that the shock waves from these stellar explosions can travel at incredible speeds, often reaching thousands of kilometers per second? These shock waves compress and heat the surrounding interstellar medium, setting off a chain reaction that can lead to the birth of new stars. Imagine the immense power needed to ignite star formation on such a grand scale, as if the universe is breathing new life into itself with each explosion. Here's a curious fact. Some supernovae can outshine an entire galaxy, albeit for a short period. This extraordinary brightness is due to the immense release of energy during the explosion, making these events visible across vast distances. For a brief moment, a single star's demise can rival the luminosity of billions of stars combined. It's a humbling reminder of the scale and intensity of these cosmic events. Speaking of intensity, consider this. Supernovae can create cosmic rays, high-energy particles that travel through space at nearly the speed of light. These particles originate from the shock waves of supernovae and can eventually reach Earth, where they influence the atmosphere and even the evolution of life. The idea that particles from distant stellar explosions could have an impact on our planet is truly mind-boggling. And here's something truly fascinating. In some cases, the remnants of a supernova can collapse into a black hole. When a massive star undergoes a supernova, its core can become so dense that it forms a region from which not even light can escape. These stellar remnants are among the most enigmatic objects in the universe, with gravitational fields so strong that they warp space-time itself. Imagine the remnants of a star becoming a cosmic abyss, a place where the laws of physics as we know them cease to apply. Here's an intriguing tidbit. Supernovae can sometimes create peculiar non-spherical shapes. Rather than a uniform explosion, some supernovae eject matter in jets or lobes, creating asymmetric patterns. These shapes can be influenced by factors such as the star's rotation or magnetic fields. The variety of forms these explosions can take adds another layer of complexity and beauty to our understanding of stellar deaths. Did you know that the study of supernovae has helped refine our understanding of dark energy? Observations of distant supernovae have provided evidence that the universe is not just expanding but accelerating in its expansion. This revelation has profound implications for the fate of the universe and has led to the concept of dark energy, a mysterious force driving this acceleration. Supernovae, in their explosive demise, have become key pieces in the puzzle of cosmic evolution. Here's another interesting fact. Some rare supernovae involve stars with incredibly strong magnetic fields, known as magnetars. These stars can have magnetic fields 1 trillion times stronger than Earth's. When they undergo a supernova, the interaction between the magnetic field and the explosion can lead to unusual phenomena, such as gamma-ray bursts or incredibly bright and long-lasting afterglows. The presence of a magnetar adds a mesmerizing twist to the already complex tapestry of supernova events. Imagine this: certain supernovae, known as pair instability supernovae, are so powerful that they completely disintegrate the star, leaving no remnant behind. These explosions occur in exceptionally massive stars and result from the production of electron-positron pairs in the core, which destabilizes the star. The sheer energy of these explosions obliterates the star entirely, scattering its elements across the cosmos, a final act of cosmic generosity. As we delve deeper, consider that supernovae are also crucial to studying the early universe. By observing supernovae in distant galaxies, astronomers can look back in time, capturing snapshots of the universe when it was much younger. These observations help us understand the conditions and processes that shaped the cosmos during its formative stages. In a way, each supernova is like a window into the past, offering glimpses of the universe's ancient history. Speaking of history, did you know that supernovae have been recorded by ancient civilizations? Historical records from China, Japan, and the Middle East describe bright guest stars appearing in the sky, often linked to supernova. These observations provide valuable insights into the chronology and frequency of supernovae, connecting us to a long tradition of human curiosity about the stars. Here's a particularly surprising fact. Some supernovae can produce exotic forms of matter. This state of matter, believed to exist momentarily in the cores of exploding stars, consists of free quarks and gluons, the fundamental building blocks of protons and neutrons. The conditions in a supernova can thus recreate states of matter thought to have existed only shortly after the Big Bang, offering a glimpse into the universe's earliest moments. And finally, let me share that supernovae are not just about destruction. They are a testament to the cyclical nature of the universe. The energy and elements released during a supernova enrich the interstellar medium, setting the stage for new stars and planetary systems to form. From the ashes of a dying star, new worlds can emerge, illustrating the eternal cycle of birth, death, and rebirth that defines our cosmic story. With these fascinating insights into the nature of supernovae, I hope you feel a deeper connection to the universe and a sense of awe for the grandeur of cosmic events. As you let these thoughts settle, may your dreams be filled with the wonders of the stars and the mysteries of space, where each supernova contributes to the ever-evolving tapestry of the cosmos. Let me share something intriguing with you. Not all supernovae are the result of massive stars exploding. Some are caused by white dwarfs, which are the remnants of stars like our Sun. In particular, when a white dwarf is part of a binary system and accretes enough material from its companion star, it can reach a critical mass and undergo a type of supernova known as a Type 1 supernova. This process is like a cosmic balancing act, where the delicate tipping point sparks a brilliant explosion. And here's another fascinating detail. These Type E supernovae are incredibly uniform in their brightness, making them essential tools for measuring cosmic distances. Because their luminosity is consistent, astronomers can use them as standard candles to determine how far away they are. This has been instrumental in mapping the expansion of the universe and understanding its vast scale. Speaking of cosmic scale, did you know that supernovae can leave behind stunning nebulae, which are often vibrant and complex in their structure? The Crab Nebula is one such remnant, created from a supernova first observed in the year 1054. This nebula is still expanding, with its intricate filaments and gases spreading out across space, a testament to the enduring legacy of stellar explosions. Here's a truly surprising insight. Supernova explosions can trigger the formation of new stars. When these powerful blasts send shock waves through the interstellar medium, they can compress nearby gas clouds. In this way, the death of one star can lead directly to the birth of others, a beautiful cycle of cosmic renewal. Consider this. Some supernovae produce neutron stars, which are incredibly dense objects made entirely of neutrons. A neutron star is so dense that a sugar cube-sized amount of its matter would weigh about as much as all of humanity combined. The existence of such dense objects challenges our understanding of matter and physics, offering tantalizing glimpses into the extreme conditions possible in the universe. And here's a delightful tidbit. Neutron stars can spin at incredible speeds, sometimes several hundred times per second. These spinning stars, known as pulsars, emit beams of radiation that sweep across space like cosmic lighthouses. The regularity of these beams makes pulsars precise cosmic timekeepers, helping scientists test the laws of physics in extreme circumstances. Did you know that some supernovae are so powerful they can outshine entire galaxies, even if only for a brief moment? These extraordinary events are known as superluminous supernovae, and their sheer brightness can be 100 times greater than typical supernovae. The mechanisms behind these events are still not fully understood, adding an element of mystery to their brilliance. Here's something you might find surprising. The concept of a supernova isn't just limited to our universe. Theoretical models suggest that in certain hypothetical universes with different laws of physics, supernova-like phenomena could occur with variations in their behavior and consequences. This reminds us of the endless possibilities and the boundless creativity inherent in nature's design. Speaking of creativity, some supernovae are thought to result from the merger of two white dwarfs. When these dense stars collide, they can trigger a thermonuclear explosion, leading to a unique type of supernova. The idea of two ancient stellar remnants merging in a fiery finale is both poetic and awe-inspiring, showcasing the diverse pathways to stellar death. Here's something that may surprise you. Supernovae have played a crucial role in shaping the chemical makeup of galaxies, including our own Milky Way. The heavy elements forged in the intense heat of these explosions are dispersed throughout the galaxy, enriching future generations of stars and planets. This cosmic recycling is why we have elements like iron in our blood and calcium in our bones, connecting us to the stars in the most fundamental way. Imagine this. The study of supernovae has contributed to solving one of the most significant mysteries in physics, the origin of cosmic neutrinos. These elusive particles are produced in vast quantities during supernovae and travel across the universe at nearly the speed of light. Detecting them on Earth has provided insights into the processes occurring deep within exploding stars, a window into the universe's most violent events. Here's an intriguing fact. The energy released by a single supernova can outstrip all the energy the Sun will emit over its entire lifetime. In just a few seconds, a supernova can unleash a staggering amount of power, highlighting the immense forces at play in the cosmos. Did you know that supernovae have even influenced the development of technology on Earth? The study of these stellar explosions has spurred advances in telescope design, detector technology, and data analysis techniques. In pursuing knowledge about the universe, we've also enhanced our ability to observe and interact with the world around us. As we ponder these incredible facts, remember that supernovae are not just destructive forces, but also creators of new possibilities. They remind us of the interconnectedness of all things, from the tiniest particles to the most massive stars. Each supernova is a chapter in the cosmic story, a brilliant moment that illuminates the universe and enriches our understanding of it. As you drift into sleep, let the wonder of these celestial events fill your dreams, guiding you through the vast expanse of space and time.